Hey everyone, thanks for joining in. My name is Shashank. I'm a partner sales engineer with Dataiku. I work very closely with our tech partners like AWS. I have with me Ayan Ray from AWS. Ayan, you want to quickly introduce yourself?
Hey, thanks, Shashank. This is Ayan Ray, Senior Partner Solutions Architect, GenAI at AWS.
Thanks, Ayan, for joining in. So, what's in our agenda for next 30 minutes? So, going to start with talk about how Dataiku and AWS works together. Then we dive into more towards the GenAI offering from Amazon Bedrock, as well as Dataiku LLM Mesh. That will be followed up by a solution demo, where we'll showcase how we compare in-context learning and fine-tuning using Dataiku LLM Mesh powered by the models from Bedrock. And then we'll have some time for Q&A for everyone. So let's start. How Dataiku and AWS work together. So Dataiku is the analytics workbench solution that sits on top of your AWS cloud infrastructure. It provides visual and coding capabilities for developer to build applications and then take it from development to production using those components. Dataiku behind the scene take advantages of all different AWS capabilities, starting from storages to database for elastic compute, as well as AI services like SageMaker and Bedrock. This will help organizations to take advantage of the scalable compute from AWS, as well as the key built-in AI capabilities like models coming from Bedrock, hosting capabilities from SageMaker, etc. Now, overall, this help organizations to like empower business teams to take advantages of visual components of Dataiku and then use the AWS services. It also help create a collaborative environment where both business teams as well as data scientists can work together at the same place. With that, Dataiku also provides governance feature and take capabilities of AWS like auditability, version management, and build a safe governed environment where applications can be fully monitored end to end. Dataiku was the AI/ML Partner of the Year last year and hoping to win that again this year. Okay, so this is a 10,000 feet view of the architecture and showcasing some of the key capabilities that Dataiku take advantage from AWS. So we have a full connectivity within databases like Redshift and RDS, where you can not only just connect, but also can push compute back to this database using visual components. Anywhere where there is a requirement of distributed processing, whether it's about running Spark jobs, deep learning, machine learning, that's where we use AWS EKS. That is by default comes within Dataiku with set of nodes, and that is something teams can scale up and scale down based on their needs. Other than that, as I mentioned, we also integrate with SageMaker, take advantage of all the large language models available through Bedrock and its other APIs. Now, this is a set of some of our joint customers who are leveraging Dataiku in combination with AWS services. Okay, so now we get into GenAI. We'll start with Amazon Bedrock offering. I'll ask Ayan to cover that.
Sure. Thanks, Shashank. So, hey everyone, I'm a solutions architect, as I introduced myself. And as a solutions architect, I work with a lot of partners and customers. And there are few common questions that they always ask me. First of all, they ask me that there are so many foundation models to choose from. How do I choose a model which best fits my use case? The next question that they ask me is that how can I build and deploy foundation models quickly to build generative AI applications? And the most common question that I always face is that how can I keep my data private and secure while building generative AI applications? And that's the reason we built Amazon Bedrock, a fully managed service from AWS that offers you a choice of high-performing foundation models from leading AI companies, along with a broad set of other capabilities that helps you to build and scale your generative AI applications. With Amazon Bedrock, you can easily customize your foundation model using retrieval augmented generation or fine tuning. You can also create managed agents for performing complex tasks such as uh, managing an inventory or booking a ticket. And the good news, Amazon Bedrock is fully serverless. That means you can do all that without having to worry about maintaining and managing your own infrastructure, which is in any ways an undifferentiated heavy lifting for you. You can help me to move to the next slide, Shashank. Now, generative AI as a field is moving at an extremely fast pace. So fast that practically a new innovation is happening every day. So it might so happen that by the time you complete your development cycle and you're ready to move to production, a faster, cheaper, or a better model is available. Now, what do? You have two options. You delay your product release, but that will lead you to lose out on the competitive advantage, or you can compromise on the user experience or margin. But with Amazon Bedrock, you don't have to do either. Amazon Bedrock provides you an unified API that through which you can access foundation models from leading AI companies like Anthropic, Cohere, Meta, Mistral, Stability AI, AI21 Labs, and we also have our own Amazon Titan models. So that's really important. And we recently launched Converse API, which provides you an unified input and output structure for you to build foundation models, for you to build your generative AI applications. And Converse API also supports function calling. It also supports prompt translation. And if you want to do it through a visual interface without explicitly calling the APIs, you can do so using Dataiku. And Shashank will show you how you can access these foundation models through Amazon Bedrock through an easy interface, low code, no code interface, and a drop down. And moving on to the next one, that's something that I want to double click on is our commitment towards privacy and security, because that has always been a priority zero for us at AWS. First of all, none of the customers' data is used to train the base foundation models, period. Even when you're fine-tuning your foundation model, we create a private copy of the model, put it in a secured container, and that is accessible only to you. Your data is secured both at rest and in transit, and you can securely and privately access the foundation model from your own virtual private cloud without traversing the public internet through AWS Private Link. We are also compliant with GDPR, HIPAA, ISO, and CSA. So that's why you should really use Amazon Bedrock. And that's when I'll hand it over to Shashank and Shashank will show how Dataiku integrates with Amazon Bedrock.
Yeah, thanks, Ayan. This was very useful. To the audience, you just heard about all these key capabilities that built-in comes with Bedrock. Now, on top of it, I'm going to talk about what additional capabilities that Dataiku comes bring into this picture on top of your Bedrock APIs. So Dataiku recently launched a service called LLM Mesh, and there's some key capabilities that enables organizations to build GenAI applications at scale. So here what you're seeing is all these white squares on the left-hand side is those capabilities that we have built in. So starting with helping organization decoupling the application with the AI service layer. As I mentioned, like we have a visual way of you switching models. As soon as a new model comes, you don't need to change the whole application. It's as simple as switching the model, comparing the newer model, how it is performing, and then take it that to production. Dataiku also provide a secure gateway to LLM services. You have the full audit trail capabilities built in the application. You also have custom hooks available where organization can build their own hooks for PII detection, content moderation, prompt injection, or take advantages of what already has built in Dataiku. This will make sure any prompt or text going from organizations to hitting your model and coming back will go through this safety measures through the built-in capability. On top of it, we have this LLM cost card, which is a built-in dashboard which can help you monitor and manage the cost across all different LLMs that your organization is consuming. You can also use this data to put alerts for different teams to make sure to notify the teams that are responsible for managing the cost. We have connectivity to all the different hosted LLM providers, including Bedrock, Anthropic, as well as you can choose to host a local Hugging Face model within Dataiku with the same interface to consuming it when you develop the application. Uh, we also have built-in integration with vector stores, so you can use Elasticsearch, Pinecone, ChromaDB, FAS. There's different vector stores available for users to choose from. Now, apart from the LLM mesh that I covered, that's a bottom block. Those features are specifically for ops side of LLM. On top of it, Dataiku also provides some visual components to build those uh, LLM applications using our visual recipes, where you have recipes like text classification, like NLP-based tasks using LLMs. You have prompt recipe, you have a recipe to generate embeddings, and other than that, you have Prompt Studios, which is a visual interface for doing prompt engineering, which you'll see it in the demo. That's where you can connect to your data set. You have a different options for submitting user message, system message. You can see the cost estimation of running this prompt on a larger data set, as well as you can use the same interface to compare outputs from different models. Now we'll quickly talk about our use case and then we'll jump into our solution demo. So the use case we have is we have a data from a Wolf, Equinix Wolf, it's a publicly available data set. It's coming from an oil rig. And the use case that we have identified is there is a need of converting hourly nodes from coming from an oil rig to generate a summary every day by a rig operator. What we are trying to see, we can create an AI assistant that can help generate this summary every day to bring efficiency. Now, the key challenge here is that, as you know, LLMs are not specialists, they are generalists. So here we need LLM to understand the jargons and abbreviations of oil and rig domain and to generate the summary accordingly. So to test this out, we're going to use two approach. So we're going to build an AI assistant and we test out two approaches. One is the in-context learning, where we're going to use a model by sending a set of examples of already labeled data set, as well as we're going to use an approach where we're going to fine-tune an AWS Titan model and then compare their outcomes. So with that, let's dive into our solution. So we are at the home screen of the project. See, we are building an oil rig assistant using Bedrock. You can see on the right-hand side the whole revision history, the project changes. Go to the flow. So let's first look into the data set. So we have this data set uploaded here in a folder, and then I'm using a prepare recipe to engineer the data set. Turn off all the changes. So we have around 315 columns on this. We will be focused on 4 of the columns. One contains the ID, then the start date, and the early notes, as well as the daily summary. So after renaming those 4 columns, we just keep only those columns. So now we came down to 4 out of 315 columns, as you can see what I mentioned. And when we start looking into the data set, see, I have the daily summary comment. Looks like the data is unique to every day. And there is an attached list of arrays where we have the early comments available under the key bitsml comments. So let's first flatten this array. Yeah, so now we have from 1400 records, we are jumping to almost 19,000 records. And then within that array, we convert those keys into columns. Now out of this, the only column we need is the comment section. So we remove other columns. So using few of the existing processes, I was able to quickly analyze the data and then come up with the final data set that I needed for processing. So you can see we have these comments. Our plan is to concatenate these comments so that we can create like a one input text for the LLM and then use that to generate the summary. So after this prepare step, we do furthermore cleaning on this. And then this one thing that I want to highlight is we created a prompt column, and this will be required for fine tuning. So we can't get some instruction to the early comments that we have after concatenating it. You are saying consider you are an oil rig operator who is responsible for documenting early nodes at an oil rig and generating a summary of the nodes at the end of the day. So provided concatenated our nodes and generate the summary. So now we have the data set ready. Now we get into in-context learning first. So for this, we'll be sending some examples to the um, LLM. So what I did, I just take two records out of it by using filter and then do a cross join all the records. So now we have the same data set, but with four additional columns of early comments and completion as an example, same value to the whole data set. For fine tuning, we just split the data set into train and validation, and then using a fine tune recipe. This is where we choose AWS Titan model. As you can see this warning that this model will not be directly available as you need to provision the throughput for this in Bedrock, which will come later once you train the model. So we choose that, we provide the prompt column, completion column. You choose to provide hyperparameters, or you can opt to use the default values. So it will generate an model output here. If you go in Bedrock, this model will be registered under custom models. And then you need to provision throughput for these models. Once you do that, it will be showed up under provision throughput. And from here, you can copy the ARN, get into Dataiku. This is the Bedrock connection. So we have the models checked, which will be available for LLM processing, as well as the embedding models. And this is under the custom model. You can add that ARN, name the model, define what type it is, choose the handling mode based on this is the Titan, so we'll be choosing Amazon Titan. And if you have it on an inference like pay as per usage, you can provide the cost also. This will help Dataiku to showcase you the estimated cost to run this on a larger data set. So we fine tune the model. So now we have the data set and models available for us to do prompt engineering. That's where we go into Prompt Studios. In Prompt Studios, this is the advanced mode where you can see you have an option to put user message, system message. This is where you choose the model from the list of models you have available. So here you can see under Bedrock, now this is my custom model as well as the Titan text that we're using as a base model. You can provide the additional data set, like you can input the columns from a data set by using this double curly brackets and then map it to a column. At the bottom, you can choose how many records you want to sample it on to do the prompt engineering. And then you can run this prompt and it will generate the output showcase in the blue. Apart from that, in the settings, you can also put some validations on top of it. Like you can restrict the output should always be in a JSON format in a specific structure. And if it does not, it will throw an error. So this is where we run for text given light. We get the output. Then similarly, we did the same thing with using the fine-tuned model. The only difference is there we are not providing any input columns. We are just asking the model to generate the summary since it has been already been fine-tuned on that. Now, once you do that, you have an option to compare these models. Here you can also see for Titan model, it is showing you the cost of running this same records over like 1,000 requests. And based on the model you select, it will display the cost. When you compare, you can choose this compare method to compare the output side by side. To open up this kind of screen, and you can see you can compare the text. You can compare this text with the actual outcome also to validate how accurately it's responding and do the further prompt engineering to improve the accuracy. Now, once you're satisfied, you can deploy these as recipes. So here you see we have the same prompt configured as a recipe here. Choose, yes. And we have the user message. system message, the same columns that we selected. And on top of it, you can do further settings for that. So it generates the output, the final output of the LLM. We have right now for this demo because we have shortened it to 4 records. So you can see the output here. Similarly, for fine-tune model, follow the same process. Again, a prompt recipe, you're configuring the column, rest information remains the same, and you generate the output. So now with these two, we are able to generate these two outputs from prompt studios. We can able to compare the text, the cost, but this does not cover the LLM evaluation metrics that are available. So for evaluating on a metrics, we have a new recipe called evaluate LLM. This is where you can define what kind of task it is, choose the input column, the output column, the ground truth column, which is coming from the labeled data set. And then you can provide the evaluation name for each run, choose a matrix out of pre-built metrics that you have available, provide the embedding and completion LLM column. You can also add your own custom matrix to this eval store. You can write a small Python function and add it to it. So when you run this output, it will generate this eval store and the data set associated to it. And here you see I did the 2 runs, one with the base model outcome and one with the fine-tuned model outcome. And I have the stats coming out of it based on the metrics I selected. I can also go and compare these metrics side by side. Yeah. So you can see the metrics output and you can compare these over time as you run more and more different you choose different models to compare for, and then you can generate these metrics and then use this data set to take a decision which model should be good for you to move it to production. You can also do similar row by row comparison for each of these metrics. So the objective here is not to say which approach is better, it's just to show the simplified process of quickly using a base model as well as fine tuning an existing model, compare the approaches and then take the decision accordingly. The approach may differ based on the use case. Also, in all these approaches, there are multiple options to further improve the accuracy of the outcome. For example, for fine tuning, the data set was very small that we use. It can be a larger data set. You can have better prompt as an input to generate this. Similarly, in context, nowadays, the token limit is very high, so you can put more examples. Like we just used 2 examples, you can have 4 or 5 examples going through the model, as well as change the input prompt, give more specific instructions to generate the right output. So with this, in this demo, we showcased specifically how these 2 approaches can be applied in Dataiku using Bedrock models, using visual features from end to end, starting from preparing the data, comparing these 2 approaches, doing the prompt engineering, and then finally evaluating the outcome. Thank you. Let's get back to our slides. With that, we come to the closure. We have one more slide to go. So what we are trying to give you a takeaway message is by joining these 2 technologies, Dataiku and AWS, you can empower broader set of workforce within the organization to do analytics on their own. It also helps you take your all the projects which are sitting in dev as a prototype faster to deployment by using a lot of visual components that can help you not only take your projects, containerize it, deploy it into production using clicks in the interface, but also making sure that you have a proper monitoring and have a trust on the solutions that are running in production. The monitoring can involve monitoring a model or a data set for a quality, or even making sure the right number of APIs hitting the right number of requests are hitting your end APIs. So all these built into the application using underlying AWS technologies to simplify the data science project lifecycle for the organization.